So in this session, we'll see about the disk native command queuing. Command queuing, in the sense, there are two diagrams here, without optimization and with optimization. The meaning of optimization: reducing the seek time. If you reduce the seek time, overall performance will be improved, because if seek time seek time is reduced, then computation time will be increased on. Seek time is what? Time required for the IO controller, right? Time required to position the IO controller over the disk is called as seek time. That is to be optimized or reduced. In a first diagram, it follows the FIFO order or FCFS, that first come first serve order. So what happens is, there are four jobs. Say they are the input request, in the sense, data read request there. So A, B, C and D, they come sequentially, so they will be processed sequentially. But see the disk in the diagram, first diagram, data A, which resides at the innermost track, followed by C, followed by B, as well as followed by D. So what happens is, right, initially you have to position the read write over A, that is innermost track. Then immediately after that, where to place? So you have to come almost outermost track, right? You have to change the position of the read write head. In between C comes, but still C will not be read. So what we could do is, instead of this following the sequential order, we can go with the optimal seek time order. Optimal seek time in the sense, so even though you have to anyhow as per the disk controller request received by the disk controller, even the data C should be read. That's why what happens is, even data C will be optimized, in the sense, A followed by C will be read, followed by B will be read, and hence finally D will be read. This is what IO processing order, updated IO processing order, based on the place or location where the data is stored, just to optimize the seek time. Getting? No? Very simple concept. Next topic is about the RAID. So RAID stands for redundant array of inexpensive or independent disk. What is the meaning of RAID? Say this is one of the key requirement, key challenge, as well as key requirement of all the industry, IT industry as well as non-IT also, because these days it is the challenge as well as one of the requirement of all the organization to maintain the data in terms of digital format, right? Why it is key requirement? You just analyze. Suppose you are purchasing, you want to purchase an item from online store, say Flipkart or Amazon. What is the first step? You need to create an account. Your account should be created first. So as soon as you create the account, their database, I mean the server of that Flipkart or Amazon or whatever the store it may be, there in their database your data will be updated. It will be added for the first time. Then it is to be maintained properly. Maintaining means what? You want to purchase, suppose you are purchasing an item, say cell phone today, that order detail, order tracking, then billing, everything should be updated for today's date, right? And it should be retrievable in the sense, suppose after 6 months or 1 year you want to check that billing details, that data should be available. Once you log in, you should be able to retrieve those. You not only after 6 months, it should be retained, even it should be kept even after 6 years. If you try to, even after 6 years, if you want to retrieve the data from that particular account, then it should be available, right? This is one of the key requirement. Hence storing the data permanently in the server, on the server, is one of the key challenge of all the organization, all the IT as well as non-IT organization. For that purpose, concept of RAID is introduced. RAID technology is used. RAID technology in the sense, RAID stands for redundant array of independent as well as inexpensive disk. Okay, what do you mean by array? Array means what? Array is nothing but a collection, right? Collection of similar elements as a set, common set. So this collection of elements, so implementation we are going to discuss. RAID implementation methods. One is software, other one is hardware. So we can using software modules we can simulate the behavior of the RAID. But RAID has got different strategies in it. There are different levels of RAID like striping, mirroring, parity, and so like that. Similar, there are 6 to 7 different levels of RAID. Hardware RAIDs are available. Not all the hardware RAID facilities or functionalities are available in under software. So using software we can virtually implement the single physical disk as a several disk drive. So several disk drive, that is using software RAID. Then most important thing is about the hardware RAID. So hardware RAID has got different levels, as I told. Uh, it has got a controller circuit called as RAID controller, the hardware unit, as it is told earlier, redundant array of independent as well as inexpensive disk it is. So different levels of RAIDs are nothing but striping. First concept is about striping, other one is about the mirroring. Major concepts of or major hardware RAID implementation involves these strategies. What is the meaning of striping? Let us just go in detail about the striping. Suppose you have got 5 physical disks with you. Each disk capacity is of 10 GB. What is the capacity of the disk? 10 GB. Okay, 10 GB is the capacity of disk A. 10 GB is the capacity of disk B. 10 GB is the capacity of disk C. 10 GB is the capacity of disk D, as well as 10 GB is the capacity of disk E. Okay, getting no? So there are 5 disks A, B, C, D, E, and each disk has got a 10 GB of capacity. Now what striping principle tells you is, instead of, assume you have got a data, single data of 5 GB. Instead of storing that entire 5 GB of data on a particular disk A, what is the capacity of disk A? Assume all are free, all the 5 disks are free, they are new. So capacity of disk A is 10 GB, B is 10, C is 10, D is 10, and E is 10. Now the size of the data is 5 GB. You can directly, you could have 10, so indirectly we can copy on one of the disks, say A, 5 GB. So but what striping principle tells you is, instead of copying the entire 5 GB of data on a disk A, what you can do is, you can divide the 5 GB of data into, count how many number of disks are available. 5 disks are available. No, 5 equal units, and each unit you can store on one particular disk. So listen carefully, 5 equal units of 5 GB of data means 1 GB each, right? Store 1 GB each on each disk, since you have got 5 disks with you. What is the advantage? Question will come, what is the advantage? Why we are supposed to do it? Is an additional burden, the division of data, storing them separately and all. But this has got an advantage. Suppose if one of the disk fails, suppose if disk A fails, still 4 GB of data you can easily retrieve. 4 GB of data, only 1 GB will be lost. Getting no? Suppose now you think entire 5 GB of data is stored at disk A. What will happen if disk A fails? All the data, entire 5 GB of data will be filled, right? Getting no? So to retain the data, to avoid the data loss because of sudden failure of one disk, you should not rely on one disk, right? What you have to do? Divide the data, scatter them on multiple disks. If one disk fails, still you could be able to access the other parts of the data because of the availability of the other portions of the data on a different physical disk. That is what striping principle tells you. This is how does striping looks is. This is what array diagram is. So striping technique, there are striping technique. Stripe is nothing but division, data division. As you can see the diagram, there are 9 disks you can see, and see the black and gray shade, stripe 1 and stripe 2. They are stored. They are not stored on still any one disk you can consider. any one's diskette you consider. Each row has got three diskette, no? Any one diskette you can consider, but entire, even though it has got some empty portion, but still entire data is not stored on one particular diskette. What is done? It is stored in 9 different division. Check the gray shade as well as black shade. Okay, they are marked as data stripes. Data 1 as well as data 2, different stripes are stored at different disk, as you can see in the diagram. Okay, see the another version of the same diagram. A1, A2, A3 are the divisions of data A. They are stored at 3 different locations. Similarly, stripe 2 stands for different data set. Data unit B is divided into 3 parts, B1, B2 as well as B3. That is what striping is. Another important concept we have is mirroring. What is mirroring then? Mirror image, you know, right? Mirror image, having the replica of the same disk. What is the advantage of having mirroring? Having mirroring has got a lot of advantage. If one disk fails, what you are supposed to do? You can easily retrieve the same data from the another disk. That is what mirroring is. Getting now? It causes the redundancy. Mirroring, even though the mirroring causes the redundancy, but still what has happened? So what is the advantage of mirroring? Even though it causes the redundancy, but still you can access the data. Suppose a disk is totally failed. If a disk totally fails, still you can retrieve them from the redundant disk, right? So additional storages are required, additional cost you need to invest, but whatever, it ensures the data protection, data security. It avoids the data loss. Even though the data is lost from one disk, still you are able to retrieve it from the another. That is what mirroring concept is. So this is how exactly mirroring looks. There are 5 disks in each array, 2 arrays you can see. Collection 1, the left hand side there is an array, right hand side there is an array, right? A, B, C, D, E are the 5 data elements stored at 5 different disks of first array. Same mirror image, I mean entire array set is copied onto the new location. Another disk replica of array is found here, right? A, B, C, D, E, again mirrored disk array it is called as. Another important parameter, another important strategy, or you can say another important RAID technique is parity. What is parity? Again, parity is also used much in case of disk failures to identify what portion of data is lost. So parity is a method to protect striped data from the disk drive failure without the cost of mirroring. So mirroring obviously needs extra cost, requires extra cost, but how and all will come to know later in detail. Okay, please remember, instead of going for mirroring, what we can do along with striping, we can ensure parity to avoid the data loss. Okay, an additional disk drive is added to hold the parity. Special disk drive array is required to hold the parity. This parity is nothing but a mathematical construct that allows recreation of the missing data. Okay, parity is a redundancy technique that ensures protection of the data without maintaining a full set of duplicate data or mirror image. So parity calculation is the task performed or function performed by the controller circuit or RAID controller. This is how the diagram looks. So there are 5 arrays available here, and what happened is out of 5, 4 arrays are dedicated to store the data, and the 5th array is dedicated, it's a dedicated array for storing the parity value. So 4 out of 5, 4 rows are marked as, 4 columns are marked as data disk, and the 5th one is marked as parity disk. Check the diagram carefully. Okay, these are all the parity values, that 3, 1, 2, 1 and all what is marked here. This is what the parity value. Simple calculation you can see 3 plus 1 plus 2 plus 3, 3 plus 1 4 plus 2 6 plus 3 9. Okay, that is what the value. I actually perform the XOR operation, but simple understanding purpose it is given like this here. So parity values are computed by the, and they are assigned as well as computed by the RAID controller circuit as well. Then the second row parity value you can compute 1 1, stripe 2 parity value 1 plus 1 plus 2 plus 1, it is 5, then 2 3 1 3, it is 9, 1 1 3 2, it is 7, 2 plus 3 plus, that is 5 plus 2 is 7. So what happens, this frequently value will be repeatedly computed at each, whenever new data is entered or it is retrieved, each time parity value is generated and compared. Okay, it is computed. It will be compared with the stored parity value. If there is a variation in the calculation, and that is what the summation is accessed, and it is compared with the right hand side, no parity disk value. If there is a variation, then RAID controller will come to know there is a data loss. Okay, so which portion of the data is lost is identified by the RAID controller, and necessary action will be taken. This is how it ensures the protection. Okay, very very important topic. To ensure the protection, data protection, and during in case of data loss, concept of parity is introduced along with data stripe, along with striped data. Please remember. So parity is implemented with striped data set only. That is, striping is the thing, but what? Dividing the data into multiple unit. In that case only the striping will be, parity will be implemented. And if you are implementing parity, no need of having a mirror image concept. That mirroring concept no need to have. Okay, please understand. In the next session we'll discuss in detail about the RAID levels. Based on these are the three major technique. What are the three major technique? So very important topic. RAID technique, striping, mirroring, and parity are the three important techniques of RAID. And RAID levels, we have different levels. We have 0 to 6 along with nested RAID. Let us see them in detail in the next session. Thanks for watching.